Hey everyone, Jesse here. I wanted to go over a concept in Solidity that was giving me some problems, and I thought it might help if I could show it to other folks. And in that explanation, I might actually be able to glean a little more knowledge for myself in the process. So first off, I wanted to talk about what site I'm actually learning Solidity off of. It's called CryptoZombies.io. It's a free way of learning how to create your own Ethereum game. If you're at all familiar with the game CryptoKitties, this is essentially the same type of game that this group called the Loom Network has made. So instead of CryptoKitties, you can make CryptoZombies by following this pretty cool introduction course. It's completely free if you're familiar with things like Code Academy. They do everything in their own online kind of sandbox. It's really great. It's really awesome. I'd highly recommend it. Company that hosts this Crypto Zombies learning tutorial. If you kind of scroll down, this is the Crypto Zombies, and to date they have about 65,000 students, which is quite a lot. I guess worldwide that's not too many, but Solidity is new. And if you're like me and you're just starting out, this is definitely a great way to learn it. They also have their team. So yeah, getting back to what I wanted to talk about. So one of the concepts that I was kind of struggling with myself and why I decided to make this video was just the concept of mapping. So mapping is something that's kind of universal, I think, across most of the languages that I've encountered, at least, definitely in stuff like JavaScript and C++. Full disclosure, my background is not in technology. I'm not actually an engineer or a technologist or a coder or a developer or anything like that. I am actually a finance person who is trying to learn Solidity. So if you're in kind of the same boat as I am, not a developer, this is probably a video for you. So what I wanted to go over was this concept of mapping and Solidity and how I seem to have a understanding of it. So first, I guess we should get some context. So what this whole course is about is creating a contract which makes crypto zombies. And it's just kind of a brief overview of where I'm at in the course. I'm on chapter 3, and they start talking about the message sender. We can get up to that in a bit and to this whole mapping process after kind of go over what this contract is. So first off, if you're not at all familiar with Solidity, the very first line in Solidity programs tells you what version of Solidity you're using. So 0.4.19 is the version that this particular tutorial is going off of. Just doing some research. One of the things that this particular tutorial uses is a function called KEKAC256, which is a hashing function. If you're familiar with crypto technology at all, blockchain technology at all, this is a hashing function. So it basically takes a key and turns it into a hash. This function in Solidity was not available actually prior to 0.4.3. So in this case, we can actually use this function, KEKAC256, for this contract. So if you're wondering about why you need to indicate which version, there's a good reason. So moving on. So our contract is called Zombie Factory. It's going to go on the blockchain. It's going to be called Zombie Factory. This first line is an event. So how to interact with this contract? Well, this contract is going to be listening for and sending out kind of events into the world at large. And if you go down to, where is the event? What's the name of the event? New zombie. Here. So in this function, which is where we're actually going to be updating, this is the firing of this event, new zombie, which fires off this event. So this is going to be what clues in our external kind of listeners that something has happened. So a JavaScript program, this event is going to let every other contract on the blockchain know that something happened from this contract. And then your JavaScript programs, your C++ programs, whatever is going to say, okay, this contract Zombie Factory just sent out this event called New Zombie, so let me do something with it. So that's how this contract is going to interact with the blockchain, and from there, how it's going to interact with external programs. So they create a struct called zombie, which has two attributes, the name and the DNA, and it's all part of this contract. So everything that you're creating is part of a single contract. So we're going to create an array called zombies, which is an array or a database of these zombies. And then the mapping is kind of what I wanted to talk about. So this is something that I was struggling with, and this is the main reason why I wanted to make this video. So in this case, and so for Solidity, this syntax here is essentially creating a key value pair between two different data types. So what I wanted to go over was this just basic concept of mapping in Solidity, and how it's essentially the core of how the blockchain technology works in terms of sending and receiving information from contracts, or even from wallets, or pretty much how the whole blockchain technology works. So in this case, what you're essentially doing is creating a database called zombie to owner, right? And this zombie to owner can have multiple kind of values inside of it. So in this case, let's say it has 3 values. Well, what kind of values does it have? Well, we have address values, because this mapping says that we have address values tied to this variable. So these address values look like long alphanumeric strings. So you can have one value equal to that, another equal to that, another equal to that. In theory, you would have different address values and each of these different elements of this array. And these different addresses correspond to unique IDs or elements. Now in this case, the elements that are tied to each of these address values are actually unsigned integers. So you can kind of think of it as A1 ID is tied to this address. A2 ID is going to be tied to this address. Now, you don't need to actually increase by 1. You can say that the ID 256 is actually tied to this address. And of course, each of these different addresses are actually going to be different values. So they can be any kind of alphanumeric string. And in order to get access to this particular address, you have to refer to it by this unsigned integer ID. So to read this line, you're essentially saying, I want to create an array or a database called the zombie to owner filled with addresses. And how do I access these addresses? I access them by unique keys that are, in this case, are unsigned integer values. For every key, there is exactly one value associated with it. So what does that mean? That basically means that in this case, 1, 2, 256, this is all of our keys for this particular variable. One thing you cannot have is a key that matches another key. So you can't have 1 and 1, because if you try to access this variable through the one key, well, what you have now are 2 keys that point to 2 different memory values, and you're going to get an error. So that's this line. So what you're doing is creating an array or a map of addresses that are identified by unique unsigned integers. So if you look at the next line, you're doing a similar thing, only now you're replacing the key value pair with different types. So in this case, you're going to create an array or a group of integer values. So let's say 3 tied to a unique address. So it's reversed in this case. So what this says is at this key in this variable, give me the value that's stored there. So in this case, it's 3. So this is useful for specific entities that are communicating with this contract. So if an entity, and for blockchain and Ethereum, an entity can be another contract, or it can be a wallet owner who wants to communicate with this contract, Zombie Factory, they're going to send instructions somehow to one of these different functions, and along with that interaction, they're also going to send a unique identifier called message.sender, which is the address of the person or smart contract who called the current function. So this is why we have, in this case, a mapping of addresses to unique ID unsigned integer values. So now we can actually get to where we're going to be using this. So in this lesson, which is lesson 3 of the CryptoZombies lessons, in part 2, the first thing we have to do is we have to, after we get back the new zombie's ID, update the zombie to owner mapping to store message.sender under that ID. So what this means is we basically want to take an address and store it to a unique ID key. So which one of these two maps are we going to be using? Well, we're definitely going to be using zombie to owner, and we're going to map our ID here to a unique address. So we're going to be storing an address at a unique ID key. So how do we do that? We do zombie to owner, which is our variable, and at a specific ID, we want to store the sender's address. So this line is saying, at this key, store the address of the person who triggered this function. So now we actually have a unique user or entity or whoever called this contract stored in our variable, zombie to owner. Then we want to increase the number of zombies for this particular owner. So now we're going to be accessing this mapping at this address because it's mapped from an address, and we want to increase it by a number. So they give you an example here in Solidity. You can increase an unsigned integer with ++, just like in JavaScript. So we're going to increase the value that's stored at this key. So we know that this variable has stored unsigned integer values, and they are accessed by unique addresses. So this is the unique address, and at this unique address and this variable, there's going to be an integer value. And what are we doing once we've accessed this entire value? We're going to increase it by 1.